Hello, and welcome back to the course on Physics for Engineers. We are still on the 8th chapter of this course, which is all about oscillations and waves. So before we proceed with this lesson, let us first review some of the lessons or concepts that we have discussed in the previous lessons. So we have discussed about periodic motion and mechanical waves in the previous lessons. We also have discussed about transverse waves on a string. So for this lesson, we will now start our discussion about sound waves. So actually, starting with this lesson until the last lesson of this chapter, we will all be talking about sounds. So for this lesson, we will be talking about sound level and intensity. So first, let us define what is sound. So sound is basically a longitudinal wave, and it's also a mechanical wave, meaning it needs a medium in order to travel. So it needs a solid, a liquid, or an air medium. So sound has an audible range for us humans. So this audible range is specifically just for us humans. For humans, the audible range is 20 hertz to 20,000 hertz. So these are the range of frequencies of sound that we can hear. So below 20 hertz, that's what we call infrasound. We can no longer hear infrasound, but we can actually feel it. So whenever you feel scared, that could be due to infrasound. So usually movie makers use infrasound. Movie makers, especially in horror movies, use infrasound in order to scare you. So if your speaker can accommodate infrasound, then it can be broadcasted to you and you will feel scared. Some animals like ants and elephants also communicate using infrasound. Ultrasound is the frequency above 20,000 hertz. So us humans cannot also hear frequencies above 20,000 hertz, or we cannot hear ultrasound. But some animals can hear ultrasound. And in fact, they actually communicate using ultrasound. So example of that are dolphins and bats. So they actually communicate using ultrasound. So the speed of sound actually varies with different materials. So in air, it's around 340 meters per second. So the speed of sound is fastest in solids or in more compact objects, and slowest in gases. So the loudness of sound is actually attributed to the intensity of the sound, and the pitch of the sound is actually dependent or attributed to the frequency of sound. So when a sound is loud, meaning it's intense, and when a sound is high pitch, meaning it has a high frequency. So sound are also just pressure fluctuations in a medium, say in air. So there are compression or high pressure regions, and there are rarefaction or low pressure regions. So in the compression regions, these are high pressure regions, so the particles are closer together, and this actually corresponds to the crest of the sound wave. And the troughs of the sound wave, the low pressure region, they actually correspond to the rarefaction or the low pressure regions. So basically, when you generate sound, you're just basically creating pressure fluctuations in air. So you generate compression regions and rarefaction regions. You will notice that in compression regions here, the white curves, you will see that the particles are compressed. But in the black regions here, you will see in the rarefaction regions, the particles are farther apart. So sound waves are also spherical in nature. So when you create sound waves, you generate waves in a spherical manner, such as this one and this one. So let's now go to the sound loudness or sound intensity. So the sound intensity obeys the inverse square law for intensity. So the intensity at a certain point is actually inversely proportional to the distance. So I1, the intensity at R1. So R1 is the distance from the sound source to this point, to the point 1. R2 is the distance from the sound source to point 2, the second point, or the second speed. So it's inversely proportional. I1 is in the numerator, R1 is in the denominator. So let's now go to sound intensity level. So usually it's just basically intensity, but with respect, you measure the intensity with respect to the threshold of hearing. So the threshold of hearing is the intensity where you start to hear sound, and it's actually equivalent to 1 times 10 to the negative 12 watts per meter squared. So I forgot to mention the unit in the previous slide. That the unit for intensity is watts per meter squared. So power per unit area. Intensity, that's the general definition for intensity. Power per unit area. Power is watts, area is meter squared. So the threshold of hearing is I naught or I sub 0. It's 1 times 10 to the negative 12 watts per square meters or meter squared. So the sound intensity level is represented by this variable here, beta, and it's equal to 10 decibel logarithm of I, the intensity, over the threshold intensity. So the standard unit, SI unit for intensity is bel, but the commonly used one is decibel, dB, decibel. So this was named, the unit is actually named after Alexander Graham. So these are the different sound source, their corresponding intensities, and the corresponding sound intensity level. So if you have the threshold of hearing, that's 1 times 10 to the negative 12. That corresponds to 0 decibels. So you have, if I is equal to I naught, then you have logarithm of 1. Logarithm of 1 is 0, so beta is 0. The intensity level is 0. So if you have a whisper, that's 20 decibels. Quiet automobile, 50 decibels. Ordinary conversations, such as this one, around 60 decibels. And then train, MRT or LRT, noise is 90 decibels. Threshold of pain. Threshold of pain is 1 watt per meter squared. So you may think, that's just 1 watt per meter squared. But 1 watt per meter squared is actually a very large intensity for a sound wave. And that's equivalent to 120 decibels. And that is now the intensity where you will now start to feel pain in your ears, since our sound sensor, the sound sensor in our body is our ears. So 120 decibels, the threshold of pain. Okay. So let's now have an example. Okay. So intensity of sound from headphones or headsets. So the intensity of sound heard by a person whose headphones is on his ear is around 3.6 times 10 to the negative 4 watts per square meters. Assuming the initial distance is around 2 centimeters from your ear. So that's actually the distance from the headphone to your eardrums, because the eardrums are the sensitive part, 2 centimeters. So what is the intensity when he removes the headset and is a distance 12 centimeters from his ear? So you remove the headset and it's now 12 centimeters from the eardrum. So what intensity of sound will you hear? So this is the inverse square law for intensity. We will solve for I2. I1 is given 3.6 times 10 to the negative 4. R1 is also given 2 centimeters. R2 is also given 12 centimeters. The only unknown is I2. Solve for I2 and you will get this. And you will get a value of 1 times 10 to the negative 5 watts per meter squared. So it will actually decrease by 1 over 36 times. So because of this ratio, the ratio of their distances, square of their distances. So the intensity of sound that you will hear will be 1/36 times smaller as you put it on your ear. So that one. So this is just a continuation of the previous example. The same given values, but you are now asked what is the intensity level difference. So difference of the intensity level, difference of the betas, the sound intensity levels. So we already know that I2 is this one from the previous result. And we already know I1, it's 3.6. So we need to convert these two into intensity levels and subtract there and find the difference. So for beta 2, it's 10 decibels logarithm of I2 over I0. So I2 is this one. So the unit will just cancel each other out. The watts per meter squared unit will cancel each other out. And this will give us a value of 70 decibels. So that is for beta 2. The intensity when you remove your headset, and it's now 12 centimeter from your ear. So for the original intensity beta 1, so the intensity is 3.6 times 10 to the negative 4 watts per square meters. And then you will get 85.6 decibels. So you subtract the two, B2 minus B1, final minus initial, and you will get negative 15.6 decibels. So from the original 85.6 decibel, when it's in your ears, when you remove it at 12 centimeters, it's now 12 centimeters from the, your ear is now 12 centimeters from the sound source, then it will drop. The intensity level will drop by 15.6 decibel. That's what the negative sign here means. It will drop by 15.6 decibels. Okay. And that is it for this lesson. So I will see you again in the last two lessons for this chapter. So bye for now.